Thanks to the organizers, and thanks to everyone for coming here and attending my talk. Today I will talk on something a bit different on how to transform the economics and where the data center market is going, and where you will see in the next 4 to 5 years how the transformation of that industry is happening, and what is the main concern, what is the key concern when designing a data center. A bit different. So if you see, we are in the crux of this change. I don't want you to concentrate in this slide, it's a busy slide, but if you are aware of where the technology trends are going, it's shifting. Intel is coming out with the new processors called Sapphire Rapids, which is going to 56 cores. AMD is coming out with something, Lenovo, which is going to 96 cores. Going beyond, it is going to Bergamo with 128 cores. And similarly, NVIDIA with their A100 to H100 transformation is doubling the teraflops. But what does it concern us while designing the data center? If you see here, going forward, the main challenge when designing the server design or the system design to a data center design, the key challenge we are facing is the power, or the TKs, the temperature needed to cool down the systems. If you see here, CPUs are coming down to more than 400 watts, 500 watts. GPUs are going to 600 watts to 1 kilowatt. That's the roadmap going forward. Our humble network cards, network adapters are going up to 50 watts. So how do you design systems and data center to take care of this humongous power requirement? That's the key challenge the system designers like us are facing today, and the data center guys will face today. And it's not always, it's the power which we see on the system side translates to a lot of challenges when you transfer it to the data center side. Generally, it's the 40% of the power you use in designing the system goes in cooling the system, the 40% of the power. Besides that, this is a study by US University. If you see here, you require 1.8 liters per kilowatt hour to just cool the systems. If your systems is going up by 1 kilowatt, 1 unit, you require this kind of power systems. Finally, more power means more fans, more mechanical components, more, if you have air cooling type systems, more failure rates. So, and finally, that is, more power means more acoustics. For a data center guy, it's hazardous. When you go to a data center, it's full of sound. It creates a kind of a hazardous environment. All these things results in power being the key to the data center design. This I mentioned earlier. In general, the industry standard is 40% of the power goes in cooling the systems. So if you have 23 kilowatt of power, you end up paying for 35 kilowatt of power. 23 kilowatt is your business applications, IT need for the business applications. You end up using 35 kilowatts. The extra kilowatts is just to take the heat out of that systems. This is a study by the ICD, by the European Commission. This is an interesting study. If you see here, currently, if you see 2020, the maximum power requirement for ICT requirement is on the consumer devices. But going further, by 2030, the maximum amount of power requirement for any ICT will be the data center need. So there's a huge transformation happening. And why this transformation? We need more and more compute power. Compute power is good, because the way Intel is coming out with 56 cores, AMD with 128 cores, the Bergamo, NVIDIA with 800, but all this comes at a cost. All this comes at a cost where we need to be aware of it. So what's Lenovo thinking about it? What's Lenovo, being a system design vendor, thinking about it, and what we are doing to take care of these carbon emissions, of these power costs, and how do we take this forward for the design part? We have a comprehensive portfolio. We created a sub-brand. Lenovo created a sub-brand called Neptune. Sometime back, we understood that this is a This will be one of the key focus area. By the way, this was good to have. I'll talk to you something called direct water cooling, which will be must to have. When I say must to have in data center requirements, with GPUs being more and more being I'll say a first class candidate, it was good to have somewhere in the HPC. Now with AI being a dominant technology, it is must to have. A 2 CPU, 4 GPU will take you to sometime around 4 kilowatt of power per system, 4 to 8 kilowatt of power per system. It will be more than 100 kilowatt per rack. No air-cooled technology can cool more than 100 kilowatt of rack when you are talking of this kind of power densities. So we created a sub-brand called Neptune. And in Neptune, I will concentrate on 2 technologies. We have a software called Energy-Aware Runtime. We look at it from a holistic point of view. And we have direct water-cooled nodes also, direct water-cooled nodes where water goes inside the nodes. And that's, by the way, warm water, not chilled water. A warm water, I will explain you both and what does it make a difference. First, let's talk to a software called Energy-Aware Runtime. This software we had developed along with Barcelona Supercomputing. We have a very close collaboration with a lot of universities. We developed the HPC software stack with Oxford. We developed the liquid cooling with LRZ. We developed this with Barcelona Supercomputing Center. This primarily is a very, very unique software. What does it do is that it creates a power profile based on your performance need. Say you are running an application at 2.4 gigahertz, and you see, and you want to upgrade it to 3 gigahertz. When you go from 2.4 to 3 gigahertz, you see there is a 30 to 40% my power needs will increase, because as we go to the more clock speed. Do my application get 30% benefit? So it creates a profile of your application performance at various clock speeds, so 2.4, 2.6, 2.8, 3 gigahertz. It will create an application profile and see at what application profile you get the best performance to the power ratio. If you have a clock at 3, it's not always means you will get a best performance to a power ratio at 3. So it's very, very user transparent. It will reduce your clock to 2.6, saying that from 2.4 to 2.6 you are getting the best performance. After that, clocks doesn't make a difference to you. You are getting a very delta increase. So and by the way, it works with GPUs also. So it's a very, very user transparent. It has AI and ML built into it. So users doesn't have to do anything, or a system admin doesn't have to do anything. It understands on its own, creates a profile, and gives you what is the best performance to the power envelope. This I talked to you is our flagship water-cooled nodes. If you see here, it is copper piping throughout. It's not retrofitting. It's our own design where the water goes inside. It's not any specialized liquid. It's warm water, by the way. The water goes at a 40 degree. You don't need any specialized kind of a chillers for that. You need a direct adiabatic cooler or a cooler at the top. Water goes to it, goes through all the components like the CPU, if you see the memory DIMMs, the drives, the voltage regulators, and it comes out at 10 degree higher. And you require a fan at your terrace to cool that for 10 degrees centigrade. So that's a very, very unique approach to us. For you, you see here no fans, nothing, no acoustics, no fans needed. You don't have to make a 10U server to just cool it down with multiple of fans needed. So this is a very unique approach which will help you to get the power efficiency. By the way, we have multiple of servers in this with multiple configurations. See, NVIDIA, AMD, Intel, whatever suits your application needs. And by the way, this water cooling, or many times I use the word liquid, it's not only about saving the power cost, cooling cost, saving the acoustics, which are all these things I talked about. One key part of it is performance. One key part of its performance, primarily because I was working with a customer in ISRO, where we saw that air-cooled to water-cooled gave them around 6% performance increase. And this is primarily because you are able to run at a boost clocks for a long time. If you know the Intel architecture, there's a base clock, there's a boost clock. The boost clocks is significantly higher in performance, but significantly higher in power, which allows you to have a lot more cooling infrastructure. So if you are not able to take out that heat, the power profile goes down. So we are able to run at 400 watts or the boost power for a long, long time. That gives you a sense of performance in a water-cooled systems, which is not possible. Again, I'm talking to you with this inflection. By the way, we may see a single socket coming back again. Dual socket was the way to go in air cooling. In the air cooling, a single socket may come back again. But when it comes to the dual socket standard servers, along with the GPUs, it will be a water-cooled system going forward. If you want hardcore numbers, the numbers are beyond you. This is a study again. This was done in Europe. If you see here, the savings which you get by running a direct water cooling, if you see the hardware component, this is for 200 CPU nodes. Hardware part is more or less same. There is a small amount of delta increase because of the pipes and all those going inside and the infrastructure. But if you see here, there's a huge amount of performance, huge amount of savings in terms of when you go from, say, a air cooled to a liquid cooled. And it goes further if there is a 0.1 increase in terms of euro, it is mentioned. Similarly, in terms of, if you see in rupees, this will be the case. See the kind of savings we go. We have hard code numbers also available. This goes, earlier was the CPU nodes. If you see the GPU nodes, it becomes more and more imperative to use say, water-cooled technology. It goes to $1 million+ savings on the power on a 4 years. So the savings is much more outweighs the requirement of the hardware. So when it goes from, but the hardware, if you see the green one, it's more or less the same. But the savings on the power requirement is quite high. And by the way, it's not a very, very new technology. We have huge wins, more than 10,000 nodes wins in LRZ, and now we have, this is in Barcelona Supercomputing Center, where it is there with Intel Sapphire Rapids. We have 90 compute racks running around 725 CPU cores, huge amount of technology going on. I give you another example. This is in Netherlands. It's Snell, based on the Snell's law. They have a HPC system called Snellius. Again, this is purely based on water cooling technology. Going further, one of the interesting things we have seen in LRZ Germany, which I said is 10,000 nodes, is they have taken it from a carbon negative to a carbon positive. As you know, heat coming of the water is very difficult to move or difficult to take advantage of in terms of air. But when it comes of water, it's in a very, very concentrated form. And in Germany, where it's a very, very cold climate, they have used the heat which comes out of the data center to cool buildings, to heat up buildings, to heat up, say, swimming pools, purely making it a carbon negative to a carbon positive environment. So that's where people are taking the way technology forward. That's more or less sums up my talk on that, but I'll give you a few slides. What are we doing besides this a bit? We have a unique software called HPC and AI. If you are into the AI domain, it's extremely all-pervasive. It's a huge hype over it. So Lenovo has a unique software which can do HPC and the AI at the same time. Data labeling, data training, inferencing, which can encompass end-to-end. So if you have, and by the way, this is a differentiation. Why I showed to you, it's no one in the industry has a software which can do HPC and AI at the same time. Finally, we have a pay-per-use model and as well as a monthly usage model when it comes to large requirements like HPC. And it's the way we look at it, it's true scale for true HPC, we call it. Why true HPC? Because we don't, our competition more or less only gives a pay-per-use for their own components. And we, on the other hand, give all the solutions which goes up to, let it be a switch, let it be a storage, everything becomes a part of your pay-per-use model. So that's a unique offering from our side. Finally, the proof is in the pudding. There is a website called top500.org, which lists the largest top 500 supercomputers in the world. You can go Google and check it, top500.org. Lenovo is the #1 with it. with 32% market share, 162 systems, and it's spread across, if you see, our entire globe. We are the #1 systems in multiple of the countries worldwide. So all this technology, what I've talked about, is extremely proven, running in multiple geographies in the world. That's the vendor share, which I talked about. In this, we own 32% of the top 500 supercomputers in the world. That's all from my side. Thank you.